Hello everyone, Mr. Fawcett here, and we are back for part 2 of our classifying angles lesson. We only have one more page to go, so this lesson this part is going to be rather short, but there is definitely an important concept or two that I wanted to discuss, and that's going to be important moving forward. So we are down at the last page where it says angle addition postulate. So we're going to focus solely on what's in green for now. And this is basically the same as the segment addition postulate, right? We said if we have a segment, let's say we have a segment AC and B is somewhere in between those endpoints. And let's say A or BC has a length of 6 and AB has a length of 4. Right? Well, all this segment addition postulate says is if we add the pieces of the segment together, we get the whole segment. So we get 10. So this just allows us to set up different types of equations, right? I can put my variable anywhere I want. I can put my variable here, right? I can try to figure out what the whole segment is. Or maybe they tell me what the whole segment is, and I have to figure out what part of the segment is, right? So maybe I know that the whole segment has a length of 22, and I need to find just a piece of the segment. Of course, our examples can be more complicated. The algebra can become more difficult to maneuver than just simple addition or subtraction. But the idea is that you just add the pieces of the segment together to get the entire length of the segment. The angle addition postulate works the same way. It says if you have one large angle and it's broken up into two or more smaller angles, well, you can just add up the measurements of the smaller angles and they will have to equal the measurement of the larger angle, right? So in this example, we have 50 degrees plus 65 degrees is equal to the whole angle measurement, which is 115 degrees. Okay, so same idea as the segment addition postulate. We're just now breaking up angles rather than segments. There is an add-on to this. So in our angle, in this angle, the pink angle, there's this ray OB. So actually, I'll just get rid of this so it's easier to see. So we have ray OB. If that had split the big angle exactly in two, right? So let's say it split it up into 48 degrees and 48 degrees, then this would be known as an angle bisector. So an angle bisector is just a ray, a line that splits an angle into two equal smaller angles. So just like we can have a segment bisector, we can have an angle bisector. Okay, let's move on to these practice problems. We're going to get one of these out of the way. And let's do, you know what, we will do both of them. First one's pretty short, and I'd like to do the second one as well because it has some tougher algebra going on. So first things first, let's see if we can label anything. Because right now our diagram doesn't have any measurements in there, but we can clearly see that the problem does give us some. So we need to find the measurement of IJA, and we know that the measurement of AJK is 61 degrees. So this measurement in here, 61 degrees, and IJK, so IJK is the entire angle. That has a measurement of 153 degrees. We need to find IJA, so I'm going to put that in light green. We need to find the measurement of this angle. So again, this is kind of where different colored pencils or pens or even crayons can help you when you're trying to put a bunch of different things into one diagram. So using our angle addition postulate, we can add the two smaller angles together to get the larger angle. Now I don't know what the green angle is, but we can just leave that as a variable. So I can say, I'll do these color coordinated, I can say 61 degrees plus the measurement of angle IJA is going to be equal to 153 degrees, right? These two angles are my smaller angles. This angle is the entire angle. So if I subtract 61 degrees from both sides, I'm left with the measurement of angle IJA is equal to, this should be 92 degrees. So 92 degrees. Okay, on to number 2. Same idea, but now we're given expressions rather than actual numbers. So it says the measurement of HJF. So let's outline that one in red. HGF is the entire angle. So that has a measurement of 16x plus 4. We know that EGF, let's do that one in blue. So EGF, that has a measurement of 110 degrees. And HGE, so you can see our diagram's getting a little messy. This angle is 3x plus 11. And you can find your own way of organizing the information. Maybe you want to put a little fewer markings on your diagram than I do. Maybe you want to put a little more. It's really up to you as long as you are keeping everything organized. We need to just find x here. Okay, so this time we just need to find the value of the variable. We don't have to find specific angle measurement. So let me add my two smaller angles together. I have 3x plus 11 plus my blue angle, because that's the other smaller one, so plus 110 degrees. You don't have to put the degree mark. We understand that we're working in degrees, so you are allowed to leave that off. It's good to put it in your final answer, but you can forego it. You know, if you miss it somewhere in your work, that's going to be okay. That's going to be equal to 16x plus 4. So again, large angle in red is equal to the two smaller angles in blue and green. All right, let's go ahead and solve. I'm going to add the 11 and the 110 to give me 3x plus 121. I'm going to subtract 3x from both sides, so I get 121 is equal to 13x plus 4. Subtract 4 from both sides, I get 117 is equal to 13x. And then if I divide 117 by 13, I get 9. And if I divide the other side by 13, I just get x. So I get x is equal to 9. Okay, so you should have some other problems that you can try in your practice packet, but hopefully you're starting to understand the couple of postulates we've talked about over the last couple lessons, both the segment addition postulate as well as the angle addition postulate that we worked with in this video. All right, this has been Mr. Fawcett. I look forward to seeing you next time. Until then, enjoy the rest of your day.